So in today's video, we will continue our Python for Data Science series, and we're going to discuss Exploratory Data Analysis, or EDA. I'll give you an intro, discuss loading data with Python, understanding the data, handling missing values, data cleaning, data visualization with Pandas, exploring relationships in data, grouping and aggregating data, and reviewing some advanced EDA techniques. As always, this video is timestamped, so if you'd like to skip to a specific section, feel free to by clicking on the timestamp down in the description. So let's get right into it, and let's tech talk with Tyler. So if you're new to data science, EDA is your first step in understanding your data and extracting meaningful insights. But first, let's understand what EDA is all about. Exploratory data analysis is the process of examining and visualizing data to understand its characteristics. It's sort of like peeling an onion to reveal its layers of information. So in our table here, we have a breakdown of what EDA entails, from understanding its significance in data science to leveraging Pandas, a powerful Python library, for our analysis. So now, why is EDA so crucial in data science, you may be thinking? So think of it as a detective work before solving a mystery. EDA helps us identify patterns, anomalies, and potential relationships within our data early on. It sets the stage for a more advanced analysis. And speaking of tools, Pandas is our go-to library for EDA in Python. It offers data structures like data frames and functions that make data manipulation easy and simple. So Pandas is a powerful Python library used for data manipulation and analysis. It provides data structures and functions to work efficiently with structured data. Pandas is essential for data scientists and analysts because it simplifies the process of data cleaning, transforming, and analysis. Pandas can read data from various formats such as CSV files, Excel, SQL databases, and more. This versatility allows you to import data seamlessly from different sources for your analysis. So on the screen are some ways in which you can read data from some common formats. To quickly inspect the structure and contents of a data frame, you can use the head function. This function simply displays the first few rows of the data frame, which by default is 5 rows. This is useful for getting a quick overview of your data, and my lights decided to fall down, but we're back. By using Pandas, you can effectively manage and analyze your data, making it a crucial tool for anyone working in data science. In the next part of this tutorial, we will dive deeper into more advanced functions and techniques that Pandas offers. The shape of a dataset provides the dimensions of the dataset, such as the number of rows and columns. This is useful for understanding the size of your dataset at a glance. So this code snippet on the screen will output a tuple where the first element is the number of rows and the second element is the number of columns in your dataset. So the info function gives an overview of the dataset, including column names, data types, and the number of non-null values in each row. This information is essential for identifying missing values and understanding the structure of your dataset. This code snippet will display a concise summary of your dataset, showing each column's data type and the count of non-null values. I highly recommend using this function. The describe function is very similar, and it computes summary statistics for numerical columns in the dataset. This includes metrics like count, mean, standard deviation, min, max, and percentiles. The statistics provide a quick overview of the distribution and range of your data. So this code snippet will generate a summary of statistics for each numerical column in the dataset. So by using these EDA techniques, you can quickly get an understanding of your dataset structure and basic statistics, setting a solid foundation for more detailed analysis. So in the next part of this tutorial, we will explore more advanced EDA techniques to uncover deeper insights from your data. In this segment, we're tackling the common issue of missing data. Let's dive into how we identify, handle, and even fill in the gaps in our data set. To detect a missing value in our data frame, you can use the isNull function. This function returns a data frame of the same shape as the original, with true indicating the presence of a missing value and false indicating the absence. So this code snippet displayed will produce a data frame where each cell shows true if the value is missing and false otherwise. You can handle missing values by either removing them or replacing them with specified values. So the drop NA function is used to remove rows or columns with missing values, while the fill NA function replaces the missing values with specified values. Imputation is the process of replacing missing values with substituted values. Common strategies include using the mean, median, or mode of the column. Advanced techniques involve predictive modeling to estimate the missing values. The code snippet on the screen shows how to perform mean, median, and mode imputation respectively. By understanding and applying these techniques for handling missing values in your dataset, you can ensure your dataset is complete and ready for analysis. So let's explore some essential data manipulation techniques using Pandas. Removing duplicate rows from a data frame is essential to ensure the integrity of your data, as duplicate entries can lead to bias analysis and incorrect conclusions. You can use the drop_duplicates function to remove duplicate rows based on specified columns. We're leaving this just how it is. We're going to continue through. The code snippet removes duplicate rows based on the values in the specified column, ensuring each row in that column is unique. Converting the data types of one or more columns in a data frame is crucial for proper data manipulation and analysis. Different data types allows for different operations, and ensuring your columns are in the correct format helps avoid errors. You can use the asType function to convert data types. This converts the data type of the specified column to the desired data type, such as converting a column of strings to integers. Outliers are data points that differ significantly from other observations and can significantly skew your analysis. Handling outliers involves identifying and dealing with them, either by removing them or replacing them with more appropriate values. The specific method for handling outliers can vary based on your data and the context of your analysis. Listed are some common techniques for handling outliers. You can remove outliers using the z-score. This removes rows where the z-score of the specified column is greater than 3, indicating a potential outlier. You can also replace outliers with median. This replaces values in the specified column that are outside the defined upper and lower limits with the median value. By using these data cleaning techniques, you can ensure that your dataset is clean and ready for accurate analysis, with no skewed values affecting your analysis. Now that we've covered the basics of EDA, let's dive into the world of data visualization with Pandas. Pandas provides simple methods to create basic plots directly from data frame objects. These visualizations help you understand your data better by revealing patterns, trends, and relationships. Line plots are useful for visualizing trends over time or continuous variables. They help to show changes and trends at a glance. To create a line plot in Pandas, simply call the plot method on a data frame with kind equals line. Scatter plots are effective for exploring relationships between two variables. They help to identify correlations, clusters, and outliers. To create a scatter plot in Pandas, use the plot method with kind equals scatter and specify the X and Y columns. Histograms display the distribution of a single variable. They are useful for understanding the frequency distribution of data points. To create a histogram in Pandas, use the plot method with kind equals hist and specify the column you want to plot. I think we're getting the trend here with the kind equals. Pandas allows for customization of plots using various parameters such as title, labels, colors, and style. You can pass these parameters directly to the plot method to enhance the readability and presentations of your plots. Visualizations provide insights into data patterns and relationships. Interpretation involves understanding the shape of the data, distribution, trends, outliers, and any correlations present. So for example, a line plot can reveal upward or downward trends over time, while a scatter plot can show correlations between two variables, and a histogram can display the frequency distribution of data points. So by using these data visualization techniques with purpose, using Pandas, you can effectively explore and communicate your data insights. All right, let's kick things off with correlation analysis. Ever wondered how two variables interact with each other? Correlation analysis is used to measure the strength and direction of the relationship between two numerical variables. In Pandas, you can use the CORR, C-O-R-R function on a data frame to compute the correlation matrix. This matrix shows the correlation coefficient between each pair of variables, which can range from 1 to -1. A value close to 1 indicates a strong positive correlation, while a value closer to -1 indicates a strong negative correlation. The code snippet displayed computes and returns the correlation matrix for the data frame DF. Using the power of Seaborn, we can transform our correlation matrix into a vibrant heat map. Heat maps are visual representations of data where values in a matrix are represented as colors. So in the context of correlation analysis, heat maps are used to visualize the correlation matrix, making it easier to identify patterns and relationships between variables. I have a separate video for Seaborn if you'd like to dive deeper. The code snippet displayed creates a heat map of the correlation matrix with annotations and a color map that highlights the strength and direction of correlations. Last but not least, we have scatter plots, which is the classic tool for exploring relationships between variables. They're used to explore the relationship between two numerical variables. Each point on the plot represents a single observation, with one variable on the x-axis and the other on the y. Pandas provides functionality to create scatter plots using the plot function. So the code snippet displayed creates a scatter plot with variable 1 on the x-axis and variable 2 on the y-axis, allowing you to visually assess the relationship between these two variables. So by using these techniques, you can effectively explore and understand the relationship between different variables in your data set. And then you could also display this to any of your stakeholders if you're working with them. Correlation analysis provides a numerical measure of relationships. Heat maps offer a visual summary, and scatter plots show detailed pairwise relationships. Let's learn about the group by operation and aggregation functions in Pandas. The group by operation. It's used to group data based on one or more columns. It splits the data into groups based on some criteria, allowing you to perform operations on each subset of the data independently. This is useful for analyzing and summarizing data by categories. So this code snippet groups the data frame DF by the values in column_name. Aggregation functions are used to compute summary statistics for each group. Common aggregation functions include sum, mean, count, min, max, and more. These functions help to summarize the data in meaningful ways. After grouping the data and applying aggregation functions, we can visualize the group data using various plotting techniques, such as bar charts, line plots, or box plots. Visualization helps to easily interpret and communicate the results of the grouped analysis. Work smarter, not harder. By using these techniques for grouping and aggregating data, you can effectively analyze and summarize large data sets based on different categories seamlessly. Let's review some advanced EDA techniques. So imagine you have data collected over time, like stock prices or temperature readings. Time series analysis helps us make sense of this data by identifying trends and patterns. Time series analysis involves analyzing data points collected or recorded at regular time intervals. It helps in identifying patterns, trends, and making forecasts. This is particularly useful for data that changes over time. The second resampling code snippet resamples the time series data to a monthly frequency and computes the mean for each month. The third autocorrelation code snippet computes the autocorrelation of the time series data, which helps in understanding the relationship between current and past values. Next, let's dive into text data analysis. Text data is everywhere, from social media posts to customer feedback reviews. But how do we extract insights from all this text? That's where text data analysis comes in. Text data analysis focuses on extracting insights and patterns from unstructured text data. NLP, or natural language processing techniques, are commonly used for this purpose. This helps in understanding sentiments, topics, and key themes from text data. The tokenized code snippet splits the text data into individual tokens, which are just words or phrases. This sentiment analysis analyzes the sentiment of the text data, categorizing it as positive, negative, or neutral. The word cloud snippet generates a word cloud to visualize the most frequently used words in the text data. Last but not least, let's tackle handling categorical variables. In many datasets, we encounter categorical variables like gender or product type. But most machine learning algorithms prefer numerical inputs. So how do we transform this? Handling them involves encoding categorical data into numerical format, such as using one-hot encoding or label encoding. So what's one-hot encoding? This is shown in the code snippet, which converts the categorical variables into a series of binary columns, which then are one-hot encoded. The label encoding code snippet will convert categorical labels into numerical labels. And that's all that I have. I hope that by now you have a better understanding of exploratory data analysis, or EDA for short, than you did before watching this video. If you have any questions, comments, or even any new Python topics, suggestions that I haven't went over or reviewed, leave a comment down below. Also, if you aren't already, subscribe to my channel. It's free and it helps the channel out. And also click the bell icon to be notified when I post another Python series video. Thanks again for interacting with Tech Talk with Tyler. I'll see you later. I'm gonna go fix this right now.